In this video, we're going to see how we can use Microsoft Excel to carry out one-way analysis of variance, or ANOVA. Now, before we start, we need to check that we've got the Data Analysis tool pack installed in Microsoft Excel. To do that, click on the Data tab, and you should see up in this top right-hand corner something called Data Analysis if the Data Analysis tool pack is installed. In this case, the tool pack is not installed, and so we're going to need to install it. So to do that, go to the File menu and go to Options. Under Options, you want to go to Add-ins and then click Go on Manage Excel Add-ins. You're going to want to select the Analysis Toolpack and the Analysis Toolpack VBA. And now up in that top right-hand corner, you can see that you've got a new button called Data Analysis. Now in this example, we're going to try and test whether or not the average earnings of individuals are the same, irrespective of the level of their highest qualification. So whether they've got higher education, whether they've got A levels, or whether they've just got GCSEs grade A star to C. So let's begin by defining three random variables. X1 is going to be the earnings of individuals with higher education. X2 is going to be the earnings of individuals with A levels. And X3 is going to be the earnings of individuals who have only gained GCSEs. And we're going to test the hypothesis that the expectation of X1, so the average earnings of individuals whose highest qualification is equal to higher education, is equal to the expectation of X2. So in other words, the average earnings of individuals whose highest qualification is A levels is equal to the expectation of X3, which is the average earnings of individuals who have only gained GCSEs. And our alternative hypothesis is that at least one of these is not equal. Now the data we're using here comes from the UK Labour Force Survey, and it's a sample of full-time employees. And we're going to use the Data Analysis Toolpack in order to carry out one-way analysis of variance. So to do that, we click on the Data tab and we click on Data Analysis. And what we're looking for is ANOVA single factor. And we're going to click on OK. And the data that we're going to be looking at, we're going to be, and to input our data, we just need to select all of the data that we want to include. Now you note that it says here grouped by columns. That's telling us that each of the data sets relating to each of the populations are in separate columns. So we're going to select our data. We select labels in first row just to indicate that that very first row we looked at were the labels, and then we click OK. So Excel will produce a new worksheet with the results of the ANOVA test included. Now the bit that we really need to worry about is either the F statistic, this is the F statistic relating to the test, or the p-value. Now, this p-value is the probability of getting to a F statistic at least as impressive as the one that we've seen if the null hypothesis were true. Now, the p-value that we've got here is 1.188 times 10 to the minus 14. So that's a very small probability. That's telling us that the likelihood of getting to an F statistic of 33.849, if our null hypothesis were true, is vanishingly small. So because our p-value is very, very small, because it's smaller than 0.05 or 0.01, we'd reject our null hypothesis at the 5% significance level, at the 1% significance level, even the 0.1% significance level. So because our p-value is so small, we reject the null hypothesis, indicating that the average earnings across the three groups are different. And actually, that's not that surprising, given the averages that we see. We can see that the average earnings in our sample for individuals with higher education is £811.24 per week, whereas for those with GCSEs as their highest qualification, that average earnings is only £535.48 per week. So even just eyeballing the data suggests there's a difference, but what we've done here is we've been able to show using ANOVA that we can reject the null that those three groups have the same average earnings.